Okay, so here's an example having to do with both arc length and speed for a parametric curve. We have a parametric curve defined as c of t equals e to the t sine t, comma, e to the t cosine t, and the particle is traveling from time 0 up to time 2. So how far did the particle travel and how fast was it moving at t equals 1? Okay, so this really just becomes a matter of using the formula. Recall that s is equal to the length of the arc length is equal to the integral from a to b of x prime of t squared plus y prime of t squared. You can think of that whole square root thing as kind of the magic term, since it's the formula that makes all of these formulas work. It's the part of the formula that makes them all work, that they all include. So that's the arc length, and recall that speed is just equal to the square root of x prime of t squared plus y prime of t squared at some time t. So there's that magic term again. Okay, so let's see what we have here. The way the problem is set up is we have x of t is equal to e to the t sine t, and y of t equals e to the t cosine t. So we're going to need to know what x prime and y prime of t are. So x prime of t, by the product rule, is going to be e to the t cosine t plus e to the t sine t, and y prime of t is going to equal e to the t, it's going to actually be e to the t negative sine t plus e to the t cosine t, which can be more conveniently written as e to the t cosine t minus e to the t sine t. Hopefully you remember how to do your derivatives from Calc 1. All right, so let's find x prime of t squared and y prime of t squared, since we're going to need to know those. So I have x prime of t squared is going to be square e to the t gives us e to the 2t, and square of cosine is cosine squared. Then this is going to be plus, we're going to multiply e to the t cosine t times e to the t sine t and double it. Recall we're really squaring a binomial. You can recall that a plus b squared is equal to a squared plus 2ab plus b squared. So this is going to be 2 e to the 2t sine t cosine t, and then finally we're going to square the last term. That becomes e to the 2t sine squared t. Now let's find y prime of t squared. That's going to be e to the 2t cosine squared t. Now I'm doing the same thing. I'm multiplying these two terms together and doubling them, but notice that when I multiply e to the t cosine t and negative e to the t sine t, I get a negative. So this is going to be minus 2e to the 2t sine t cosine t. And then finally I'm going to square that negative, but when you square a negative you get a positive, so that gives us e to the 2t sine squared t. So I have to actually add these together so I can put them under the square root sign. Here's the thing that's kind of neat. Observe that these terms cancel because they're just equal and opposite. So what I get here is going to be 2e to the 2t cosine squared t plus 2e to the 2t sine squared t. Now, this is a plus and that's a t. Sorry, I'm trying to make these more clear as to which ones they are. Now, here's the neat thing. There are a lot of neat things in math, but let's do one of the neat things involved here. I've always said that this is a really important identity to know just for math. Watch what happens if I factor out that 2e to the 2t. I get 2e to the 2t cosine squared t plus sine squared t. My favorite term, because why? Because that's just equal to 1. So this is equal to 2e to the 2t. So this is this term. In other words, I've reduced x prime squared plus y prime squared. Turns out that it comes out to just 2e to the 2t. So that expression is equal to x prime of t squared plus y prime of t squared. And that's going to be useful because I can use that to answer both the arc length question and the speed question. So, arc length. S is going to equal the integral from 0 to 2. That's because I'm being asked about this from t equals 0 up to t equals 2 of the square root of x prime squared plus y prime squared, which is going to be the square root of 2e to the 2t dt. That equals the integral from 0 to 2 of the square root of 2. The square root of e to the 2t is e to the t. So that's not too bad. So that's going to give us the square root of 2 e to the t from 0 up to 2. And this is going to equal the square root of 2 e squared minus e to the 0. Recall that e to the 0 is just 1, so we're going to write it that way. And that's the arc length. So that's the length of the path along, that's the length that's traveled along this path, e to the t sine t, e to the t cosine t, as t goes from 0 up to 2. Now the speed at t equals 1, that's just going to be, in order to find that, I simply take the magic term, square root of x squared, of x prime squared plus y prime squared, which I know is just going to be the square root of 2e to the 2t. So that's the square root of 2e to the 2t evaluated at t equals 1. So that's going to be the square root of 2 times e to the t at t equals 1, which gives us the square root of 2 times e. So that's the speed at t. That's the speed of the object at t equals 1. And by the way, I hope everybody understands why it is the square root of e to the 2t is e to the t. Let me just do that quickly. Square root of e to the 2t is equal to e to the 2t to the 1/2, where we know that we simply multiply exponents when we nest them that way. 2t times 1/2 is just t, so that gives us e to the t. So that's why that's the correct square root. It's not going to be something like e to the square root of 2t.